All right, we're still on lesson 9.2. This is task 3. Solve systems with different types of solutions. When solving systems by graphing, you learn to recognize each of the types of linear systems from the graph. Independent systems intersect in a single point. Dependent systems graph are the same line, and inconsistent graphs are parallel lines. When using the substitution method to solve systems of these three types, 3 different outcomes will occur during the process. In task 1 and 2, you encountered 2 independent systems. The substitution method resulted in an ordered pair solution for those systems. Tasks 3 and 4 discuss what happened when using substitution method to solve a dependent system of equations and an inconsistent system of equations. All right, solve this system of equations by substitution. All right, so we've got negative 2x plus 2y equals 6, and we've got y equals x plus 3. Since the second equation is y equals x plus 3, substitute x plus 3 for y in the first equation. All right, so let's do that. So if it says we're going to take x plus y, and we're going to replace y with that because y equals x plus 3. So if we have negative 2x plus 2 times y, but in place of y, we're going to substitute x plus 3, and then that's going to equal 6. All right, so bring down the negative 2x. We're going to distribute, so we get plus 2x, and we get plus 6 equals 6. Negative 2 plus 2 cancel, 6 equals 6. So that's exactly what they've done right here. They substituted x plus 3 in for y, and they solved. All right, it says the final step of the solution process yields a true numerical fact. Notice that the middle step, negative 2x plus 6 equals 6, is true for all values of x. When a true numerical fact is the result, the system is dependent. All right, select the phrases to complete the statements. The graph of a dependent system will show 2 lines that are. All right, dependent means all solutions work. Any x I plug in here will work. So it's going to be the same line. A dependent system has infinitely many solutions because if it's the same line, that means every point on those lines are the same. All right. What equation is the result if you divide each term of the first equation by 2 and then add x to both sides? Okay, so let's look at the first equation. All right, so the first equation is negative 2x plus 2y equals 6. All right, now let's go back and read the question again. What equation is the result if you divide each term by 2? Okay, so let's divide everything by 2. So that gives us negative x, and this gives us plus y, and this gives us equals 3. And then add x to both sides. So if I add x, I'm going to have y equals x plus 3. So we get y equals x plus 3. And it says, what do you notice about equivalent form of this equation? Well, if you look back, y equals x plus 3 is the second equation. So when we took the first equation and we divided by 2 and then added x to the other side, we got the same equation. All right, so you're going to notice that the equivalent forms result in having the same equation. They can be reduced to the same thing. All right, that's all for task 3. If you have any questions, let me know. Lesson 9.2, task 4, solve systems with different types of solutions. Solve this system by substitution. All right, so we have 3y equals 2x, and we have 3y equals 2x plus 3. Notice that the left side of both equations is 3y. Since 3y equals 2x in the first equation, you can substitute 2x for 3y in the second equation, then solve for x. Alright, so let's do that. Since 3y equals 2x, I can take 2x and substitute it here. So we're going to have 2x equals 2x plus 3. And you can already see that we're going to have different outcome here because we're going to have 0 equals 3, which is false. That is not true. Okay, so 0 cannot equal 3. So that means we're going to have no solution here. Alright, so it says the result is a false numerical statement. Notice that the substitution into the second equation results in an equation 2x equals 2x plus 3. This is never true for any value of x. So 2x equals 2x, but 2x cannot equal 2x plus 3. When a false numerical result occurs, the system is inconsistent, and that means there is no solution. So let's erase this here. Alright, so let's see what the question says. Which statements are true about the graph and solutions of an inconsistent system? Select all that apply. The graph shows two intersecting lines. Nope. The system has no solution. That's true. The system has exactly one solution. Nope. The graph shows parallel lines. Yes. So they could have parallel lines. They have the same slope. They do not intersect, so there's no solution for the system. The system has an infinite number. No, that was in the last example. All right. When the equations in a linear system differ only by their constant term, 3 is the constant term here, what does this indicate about the number of solutions of the system? Well, it tells you that the system has no solution. So when we look and we see 2x equals 2x, that's true. But when we see 2x equals 2x plus a numerical value, that means this side is going to be different than this side. So there's no solution here. All right, that's all for task 4. If you have any questions, let me know. Lesson 9.2, task 5. Solve systems using substitution. The steps for solving systems using the substitution method are: solve one of the equations for one of its variables. Substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the variable from step 2 into either original equation and solve to find the value of the other variable. Use the substitution method to solve the system of equations shown. Alright, so let's look at this one right here. So we're going to take 2x plus 4 and substitute it in for y. Because this one already has it solved for y, this one doesn't have it solved for either variable, so it just makes sense. So let's say 2x plus 3 times y, and y is equal to 2x plus 4, equals 9. Alright, so to solve this, we first have to do distributive property. So we've got 2x plus 6x plus 12. That equals 9. So we've got 2 and 6 make 8x. Then I'm going to subtract 12. And I'm going to have 8x equals negative 3 divided by 8. X equals negative 3/8. Alright, if we want to find y, we're just going to plug negative 3/8 back in here and solve. Okay, let's see what our questions ask. Alright, so it says choose the equation that is already solved for y, which is what I did, and I substituted into the other one. Must y equals 2x plus 4 be chosen? Could you start with the other equation instead? Yes, you can start with the second equation, but you're going to have to solve for one of the variables first. So it would just be more steps. It would take longer, And the more steps you have, the more likely you are to make a mistake. So even though you can choose either equation, we usually recommend that you choose the equation that's already most like what it's set up to be to solve. So, all right, substitute 2x plus 4 for y in the second equation and solve. Okay, right here, that's what we did. And they got the same answer when they did that as well. X equals negative 3/8. All right, what property justifies 2x plus 3 times 2x plus 4 as this? And that is the distributive property. All right, now it says substitute negative 3/8 for x in your original equation. Okay, so they took the answer, x equals negative 3/8, and they plugged it back in for y equals 2x plus 4, and they just plugged in the negative 3/8 in for x, and they simplified to get the 3 1/4. All right, is there an advantage to substituting in one equation over the other? Well, again, this one's already set up equal to y, so when you solve this one, it's going to give you y as your answer, and that's what we're looking for. Now we have x, now we want to know what y is, so there is an advantage in using the second equation. If you look back up here, if you plug it in this one, you're still going to have to do a few extra steps to figure out what y is. All right, so it says the solution of the system is the ordered pair, negative 3/8 and 3 1/4. How would you verify that the ordered pair is indeed correct? Select the numbers and phrases to complete the statements. To verify the solution is correct, I would substitute negative 3/8 for x and 3 1/4 for y, and not sure why they have a negative there because that should just be 3 1/4, but let's see, to see if the values produce a true statement. Okay, so we have to put those in both equations because it has to make that true for both equations to be a solution of the system. If you put it in one equation, it's a solution of that equation. But to be a solution for the system, it has to work for both. Since the value of x and y are fractions, graph the system by hand would not be reasonable, a way to verify the solution, because you cannot accurately determine the exact intersection point. Using a graphing calculator is a reasonable way to verify the solution because you can find the exact x and y or the exact intersection point. All right, that is all for task 5. If you have questions, let me know.